In this video, we'll understand the concept of areas related to circles. Now, before going to the concept of this chapter, let's revise a few things here. So, first is, let's say this is the circle and with the center O. If any line from the center touches the circle, that is called the radius. So, OA and OB, here is the radius. If I join AB becomes the chord of the circle, and this length of AB, this AB from here, is called the arc. Now, if you see here angle AOB, now AOB is forming an angle. We denote this angle by theta. Now, when theta is less than 180, we call everything as minor, and when the theta is more than 180, we call everything as major. So, in this case, this AB is called the length of the minor arc. This is the minor arc here. And this entire thing is the major arc because this angle is more than 180. So if I have to, so we know that circumference of any circle is 2 pi r. So similarly, if we have to find the length of the minor arc, we call it as L is equal to 2 pi r theta by 360, where theta is the angle made by 2 radii. Again, if this is the theta we are considering, we will get the value of this, which is major arc. Alternately, if you have the circumference, if you can find the minor arc, subtract them, you get the length of the major arc. Now moving on to the area part. Now if we see here OAB, this entire part is called the sector of the circle. Now again, because the angle is less than 180, this is called the minor sector, and this part is called the major sector. Now area of a circle we all know is pi r square. So area of sector is equal to pi r square theta by 360. Again, if the angle is less than 180, you will get the area of minor sector. If the angle is more than 180, you will get the area of the major sector. Alternately, when you know the area of the circle, when you subtract the area of circle with minor sector, you get the value of major sector. So that is how you can find the length of the arc. You can find the area of the sector. Now there is one more concept called segment of a circle. Now if you see this part AB, this AB here, if I just shade it here, this part of the circle is the segment of the circle. Again, it is less than 180 here, so this is the minor segment, and the rest of the part of this triangle or circle is the major segment. Now to find the area of segment, what you do is you have to find the area of the sector and subtract the area of triangle from it. So area of segment is equal to area of sector minus area of triangle. Now area of triangle, if you have forgotten how to find, there are multiple ways of it. One, you can use half base into height, or you can use the formula of Heron's formula, that is root of s into s minus a, s minus b, s minus c, where s is equal to a plus b plus c upon 2. If you don't have the value of base and height here, you can use the trigonometric values and find the value of base and the height. We'll do a few questions to understand this concept better. The length of the minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. So if this is the minute hand, after 5 minutes it will reach here. So we are supposed to find this area. Now let's say the angle in the 5 minutes is theta. So let's, with the help of unitary method, we'll find what will be the value of theta here. So let's say this is minute and this is theta. So if the minute hand revolves in 60 minutes, so it will complete the entire, it will sweep the entire clock. So we can say in 60 minutes it will cover 360 degrees. So in 5 minutes it will cover how much? So we'll say theta is equal to 360 into 5 upon 60. This goes by 6, so 30 degrees. So in 5 minutes the angle swept is 30 degrees. Now because it is the sector here, we'll use the formula of sector, that is A is equal to pi r squared theta by 360. Unless it is mentioned to us, we'll use the value of pi as 22 upon 7. So 22 upon 7 into r square. R is 14 here. So 14 into 14 into 30 by 360. So let's just solve it here. This goes by 2. 1s are 12, goes 6, goes 3 and 11. So we can say 154 by 3 centimeters square. You can divide further and get the actual value in decimal up to 2 decimal places. So this is how you can solve the questions which are based on the sector of a circle. Now let us understand a very important type of question from this chapter. So here the question is, find the area of the segment AYB if the radius of the circle is 21 centimeters and angle AOB is 120 centimeters. So this is what the diagram will be given to you here, and we are supposed to find this segment area. So here we are given this entire thing as 120. So first we'll find the area of the sector. So area of the sector is pi r square theta by 360. Pi 22 by 7, r is given to us as 21 and theta is 120. When we solve it, we get the value as 462 centimeters square. Now to find the area of the triangle, now it is not an equilateral triangle that we can apply the formula directly, nor we are given this AB length so that we can apply Heron's formula. So we have to go by the method of trigonometry. So what we do is we drop one perpendicular OP here. Now with this theorem of circle, we know that when we drop a perpendicular from the radius on the chord, it will divide it into equal parts. So now if we take triangle, let's say in triangle OPA and triangle OPB, angle OPA is equal to angle OPB 90 degrees each. OP is equal to OP, that is common, and OA is equal to OB because they are radii. So we can say these triangles are congruent by right angle hypotenuse side congruency, RHS. So by RHS congruency, triangles are congruent, which means these two angles will be equal. So this 120 can be divided as 60 and 60. Now we'll use one of the triangles with the help of trigonometry to get the value of AB and OP. So here we have taken triangle OPA and sine 60 is equal to AP upon OA. So with the help of sine theta, we get the value of AP, and because AP is equal to PB, once we get AP, we double the value. So here AP we got as 21 root 3 by 2 and we double the value to make it 21 root 3. Right now it is not required to put the value of root 3. In the end answer, if you have time, you can put the value of root 3. Otherwise, you can leave the answer in the root 3 value also. Then to find the value of OP, we will use cos theta. Now see here, this is the theta, this is the angle 90. So adjacent is my OP. So to find the value of OP, we will use cos theta. So cos 60 is equal to 1 by 2. So with the help of that, we get OP as 21 by 2. Now we know that area of triangle is half base into height. So base here is AB and height here is OP. We'll apply that and we will get the value of area of triangle OAB as 441 root 3 by 4 centimeters square. We just learned that area of segment is equal to area of sector minus area of triangle. So we'll just subtract these two values to get the value of segment. So we just take the LCM here. So from this we can take common 21. So 21 by 4 is my common here. 88 minus 41 root 3 in the bracket centimeters square. So this is the value of the area of segment AYB. In case you have time in the exam, you can put the value of root 3 as 1.732 and solve it and get the answer up to 2 decimal places. If you don't have time, you can leave the answer like that also. In the same way, you can do more questions from the textbooks and the reference books.